Good morning. Just a few words to thank you for your presence here today. It's an honor and a pleasure to welcome you to the Open University of Catalonia. Let me introduce the work of Takashi Yosinaga, that is a researcher in the Institute of Systems Information Technologies and Nanotechnologies. That is a research institute dedicated to the promotion of information technology industries and the development of economy and society in the Kyushu area. The interest of Takashi's research is application of visualization technologies such as augmented reality and virtual reality. Specific works of Takashi's research are development of augmented reality system to support echography and development of wearable motion capture system. But I think that today, the talk that they present to us is about the use of augmented reality for teaching and learning, an issue of great interest for Open University of Catalonia and their educational model. Just mention that this activity is part of the internationalization at home program sponsored by La Caixa, and that's all. I hope you enjoy this talk. I'm sure you are going to do a great job, and I also wish you a pleasant stay in Open University of Catalonia and in Barcelona. Thank you very much.
Thank you, Carlos, for these few words. Just let me add to what Carlos has said, that Takashi has a great trajectory in the field of augmented reality, virtual reality also, and visualization, and that we have great interest in the fields of research that Takashi is actually pursuing. And we have, in fact, some lines in common. One of the lines in common that we have is an experience for the new design degree that the Open University of Catalonia is going to launch on September, in which we are building an experience through augmented reality to support students and teachers in their learning and teaching processes. And today Takashi will talk about it, and you'll have the opportunity to see this very innovative work he's doing. So just we will give the floor to Takashi, and thanks Carlos for coming for the event.
Thank you.
So Takashi.
Okay, thank you for introduction. Today, I'll speak about these topics. First of all, I'll give you a brief overview of augmented reality. Augmented reality is a term for real-world environment whose elements are augmented by computer-generated information. In other words, AR is technology to superimpose digital information into real scene viewed by user. In order to superimpose virtual object precisely, position and orientation of user or target are necessary. For this purpose, we can use mainly two types of techniques. First one is image recognition. In order to use this technology, you should see a target through a camera. After target is recognized, its position and orientation is estimated in real time. Finally, virtual object is superimposed on a target in real time. Okay, the second technique is geolocalization. As shown in the right pictures, GPS is used to get position of user. In addition, electronic GPS, electronic compass and gyro sensor is used to get orientation of user. By using them together, digital information is superimposed on real environment. The next, this slide shows display devices for AR experience. In order to use AR application, some kinds of display devices are available. For example, smart devices, personal computer, and head-mount display. Especially, smartphone and personal computer are frequently used for AR because most of people have these devices. So AR is available for everyone. Okay. Next, I'll show you some application. Recently, AR applications are developed in many fields. For example, marketing, travel, machine maintenance, entertainment, and medical and education. At first, I'll show you the most famous application, which was published by IKEA. In this application, page of Catalogue is used as target to superimpose virtual furniture. In order to use this system, we just need putting Catalogue in the room and seeing it through a camera. Then furniture is superimposed on the Catalogue. Surely, we can see it from any viewpoint. By using this system, we can check furniture's color and size before purchase of it. Okay, the second example is route guide application published in Japan. In this system, a virtual character takes travelers from station to aquarium. As shown in this video, user can reach destination by following penguins. In order to achieve this system, GPS and electronic compass are used to get users' position and walking direction. Okay, next example. AR has potential to be used for operation manual. Then this slide shows application of machine maintenance. As shown in the video, annotation and internal structure are superimposed in tablet PC. In addition, procedure of maintenance is represented by using 3D animation. By using this application, we can check the operation with seeing real machine in the same time. Okay. In the next example is 3D coloring application. This application brings AR experience to coloring book. This is very interesting. Please watch the video. There are 3 steps of procedure to use this application. The first step is filling a paper with any color. And the second step is seeing colored paper by using this application. Finally, coloring result is reflected to appearance of 3D model. Regarding this application, you can try it for free. If you are interested, please access to this URL or search with this keyword. Okay. The next, AR is also used for education. This is a use case in the Museum of Barcelona. This application was developed for viewing animated 3D model of Triceratops with photorealistic quality. As a feature of application, 3D shape of bone is recognized for superimposed 3D animation. Okay, the next example is medical AR application. As shown in these pictures, anatomical information is superimposed on the patient's body. And these applications are letting doctors and surgeons examine a holographic view of patient's internal anatomy, which are reconstructed from CT or MRI images. So we think AR allows for more advanced preoperative imaging study. Okay, next, recently, AR content becomes more interactive by using motion controller together. Today, I'll show you 2 use cases. The first example is collaboration of AR and FITNECT. Maybe you know, FITNECT is inexpensive motion capture. This sensor detects 3D shape and motion of users in real time. In order to get human motion, users simply move in front of FITNECT. So we don't need to use optical marker. Recently, many companies developed virtual fitting system by using FITNECT. As As shown in the video, 3D crosses are superimposed on the user in real time. In addition, a simple hand gesture allows user to choose items. It is very famous interactive AR system. Okay, next use case is collaboration of lip motion and electromyography. Lip motion is motion capture to get movement of hand and finger. For example, position and orientation and direction of finger. And electromyography, so-called EMG sensor, senses muscle activity of user. For example, this sensor can detect user's hand is grabbed tighten or not. By using them together, I developed virtual shooting game. In this application, lip motion is used to get the tip of finger. And bullet is shot from tip of finger when hand is grasped tighten. Today, I can demonstrate this application. Please ask me after this presentation if you are interested. Okay. I'll show you more about my works. Recently, I'm trying to use AR technology to support learning, especially for medical skill training and education. Regarding medical system, I have proposed using AR to support echography. Echography is the medical image diagnosis technique using ultrasound. Image of internal organ is obtained just by putting probe on the patient's body. Maybe it looks very easy. However, it is difficult to get echogram because the field of view is very narrow. And anatomical knowledge is required when physician uses probe to get echogram. Because of this problem, training is very important to learn skill of echography. Then we have proposed two kinds of AR system, which can visualize probe operation of skilled physician. Regarding first system, we visualize the probe position and angle recorded by skilled physician in previous. And second system, we visualize real-time instruction from remote environment. At first, I show you the visualization system of recorded operation. In this picture, red object is position and shape of internal organ. And green plane is position and orientation of probe, which are recorded by skilled physician in previous. In order to get echogram, probe operator simply move probe to overlap yellow plane to green plane. Thank you. Finally, unskilled physician get echogram of blood vessel. Okay, next. This shows remote instruction system. In this system, skilled physician instruct probe operation from remote environment. And the instruction is visualized as white probe in the patient side. In order to get echogram, operator just moves the probe to overlap it to instruction. In addition, emphasized animation is shown for adjustment of probe orientation. In order to use this function, remote doctor simply touch GUI. It's a very simple system. As a result of this research, we confirmed unskilled operator could acquire good image by referring instruction from remote environment. The next topic is use case for education. Today, I'll show you drawing navigation system. This research is just started this year. In this research, we think visualization of instruction has potential not only for medical use, but also educational use. For example, AR navigation system of drawing picture or writing text are useful for students. The main, excuse me. The main idea is shown in this picture. The procedure of drawing is superimposed on a paper, and the student can refer this information through a head-mounted display. Based on this idea, I developed a prototype of drawing navigation system. In particular, I developed two kinds of system. In the first system, teacher records drawing scene as a video in previous. In the second system, students imitate the video superimposed on a paper. In order to achieve recording system, we developed the image transformation system. As shown in this video, a drawing area, front view of drawing area is transformed to top view. By using this technique, a drawing procedure of teacher is recorded as a video, as shown in right image. The next, when students study drawing, students can see drawing procedure which is superimposed on a paper. Maybe finally, students can imitate the teacher referring this transparent video. Okay, next, I want to tell you that not only AR application, but also development tools are available for all people today. In order to develop AR application, a programming skill was required previously. But now, programming skill is not required because some development tools enables us to create AR application. Today, I'll introduce this application. Its name is Zap AR. Before demonstration, I'd like you to prepare for experience AR. Please take your smartphone from your pocket. And please access to Google Play or App Store. Next, please search ZAPAR, Z-A-P-P-A-R, and install it into your smartphone. Okay, I'll start demonstration while you are installing ZAPAR. Please keep watching demonstration. First of all, in order to create AR application for ZAPAR, we just use web browser. So we should access to the website of ZAPAR. And click Zap Code Creator. Let's have trouble. After open this page, we should log in from the login button. But okay, oh, not shown. Sorry.
Maybe full screen view from Chrome.
Okay. Please log in here. After logging, you can see dashboard page. In order to create AR application, please click Make a new Zap code or existing content. Click to edit. And click Edit Zap code content. From this step, I will register a target image to development tool. Then click button, this button, and continue. In this page, select a target image and upload it. Now uploading. After finished uploading image, click Use this tracking image button. By this operation, target is registered to Zap code creator. Okay. The next step is putting visual content on a target. We can choose type of content from these buttons. For example, in order to use photo album, we just need to upload some pictures. And finally, use select images. Then photo album is appeared on the target. And surely we can modify the position and size of AR content. Not only photo album, but also video is available. Procedure is same, just upload the file. In addition, transparent image which has alpha channel is available. There are all procedure of AR content creation. Okay, next is final step. In order to experience AR content, click Publish or Preview button. Then, unique ID is shown as circular marker. Okay. Please run your Zap AR. Maybe some messages are shown if it is first time to use Zap AR. Please ignore and skip them. Then you can see live view. Oh. You can see live view image. Please see this circular image by using this smartphone. Then download is started. After downloading, please you can see this image. Maybe you can see AR content. Okay. Maybe you can understand it is very easy to create AR content. Okay, conclusion. AR is already available technology for all people. So many kinds of application is published. And AR has potential to use of learning, Regarding my work, we developed medical operation system and drawing picture system. Finally, creating AR content has become easy. Okay, let's enjoy AR. Gracias.
Thank you, Takashi. I think it's been a really interesting introduction to augmented reality. I just wanted to point some of the things that you have shown. First, we have seen some examples of actually running applications of augmented reality to different domains: tourism, education, geolocalization, for example, the medical domain also. Education. And then we have seen some examples of augmented reality and motion sensing. This is a very interesting and exciting field of research, since you can find a lot of applications that will benefit from this combination of technologies. For example, in the medical domain, if we are looking at rehabilitation, nowadays insurance companies are a lot interested in sending patients home to perform rehabilitation processes at their homes, having the economy of cost that this implies. So with a sensor like FITNECT that Takashi has just introduced, you can build a very easy and low-cost system for the patients to have rehabilitation exercises at their homes. This is typically built in a first session with a skilled trainer that shows the patient how does the system works, and then the patient can go to his home and use the equipment by their own. For example, University of Madrid has just published a very small proof of concept about an application to to rehabilitate from arm injuries, in which the patient has to resemble the action of a goalkeeper in football. So the patient sees a ball coming to him, and he has to move their arms in order to stop the ball. And this is an exercise especially designed for rehabilitation of specific injuries. That it's working. It's very easy to mount, very low cost, and it saves a lot of costs in the rehabilitation process for people. Then Takashi has talked about visualization of instruction. This is also really interesting. For example, the research work that Takashi is doing with echographies, it's really amazing how you can, nowadays with augmented reality, how can you help novice people to perform complex processes with the aid of technology. And this is just, you have just to record the pre-operation with a skilled professional, and then use these results to train a lot of novice professionals. So there is an economy of scale very interesting in this kind of applications also, in this kind of technologies. Regarding the shooting app that you just showed, I don't know if you noticed, but it was really very sensitive, since with just this gesture of your hand, it recognized the motion sensor recognized very subtle gests and movements with your hands or whatever you are trying to use it with. I have seen an experience of Takashi with motion sensors, which you place in your arm, and then you are able to interact with digital elements. And you can, for example, grab a virtual ball and move it around with a precision which is really astonishing. It's extremely right. And the application of that, it's endless, because you are able to mix digital world and physical world with a precision and with an exactitude that allows you to build or to perform a lot of complex processes for a lot of applications and domains. So this is another area in which Takashi's work is really exciting. And then for education, finally for education, which is our topic. You've seen the experience with the drawing app, for example. We are going to apply this to the calligraphy subject in the design degree, which is going to be offered in September, but you will see. And it is again a tool to help us with economies of scale, since all you have to do is to record a complex process one time. The teacher records that process one time, and then you can reuse this process for a lot of students in different contexts. And the only thing that you need to do that is the app that Takashi is developing right now. The professor records it with a webcam. It is the only requirement. You have to record the process of calligraphy. And then a student can use either his smartphone with smart glasses, with virtual reality glasses, or smart glasses like Epson Moverio we are trying for the pilot, or any other one. So the students, when they have the glasses, they can reproduce the video with transparency. So at the same time that they see the video with transparency, they can go and perform their process. And they mix the digital reality with the real reality, with the physical reality. So it's really opening a very exciting field of research and of application, of course. And finally, I would like to underline the potential for engaging people. We have seen at the beginning some of the use cases that Takashi was showing us, and how people enjoys from this kind of interaction. This is something we have found in the experience we built for Cosmocassia Museum, right here for the Triceratops that Takashi shown, and especially how kids get engaged with these experiences. Normally, when I have two kids, when I go with my kids to museums, it's quite funny at the beginning for the first 10 minutes, but after 10 minutes, they get bored of the museum because they are always seeing the same. There is very few interaction, and they lack of engaging experiences. Using augmented reality with the high degree of possible or potential application that it has, you have a very powerful tool to engage people in the experiences that they are going on. And for kids, we have seen this with Cosmocassia, and it has worked so well that Cosmocassia now, they have opened a project with us to make this small experience that we did for Triceratops, to expand it to 5 other pieces of an exhibition that they have, which is called La Tira de la Vida, which has fossils of different ages of the Earth. And what we do is the same. We use augmented reality to create an engaging experience that explains the piece that is exhibited. Normally you see the piece, you see the bones, and you try to imagine what was behind these bones. With augmented reality, you get to know how it was in reality, or how we think it was in reality, how did it move, how was the environment around, and it's really engaging, not just for kids, but for grown adults. And this is something we want to further explore, because we see a lot of potential in augmented reality and virtual reality for education, especially. And finally, I wanted to show you a small PDF that I have copied in Takashi's laptop with just a couple of experiences that we have built for third parties outside universities. We started with augmented reality in 2011, and there we saw that it had a great potential inside UOC, but also outside UOC. And one of the goals of the university is to transfer knowledge outside of the walls of the university. So we got a lot of interest from different institutions, like Cosmocassia, for example, like Solvia, the real estate agency, and we have built experiences for them in order to help them achieve the goals that they have. So, you want to click it? Yes. We started, as I said, we started in 2011. I'll go very quickly because these are all in the web and you can access them. And inside the tourism studies, we taught students how to create points of interest in augmented reality. So they were working landscape units, for example. Les Valls d'Olot, they are interesting from a landscape point of view. So what is interesting here? So we have geographical points of interest, we have points of interest from the tourism perspective, from the economical perspective, from the historical perspective, for example. They build all these points of interest saying, okay, here you can find this, here you can find this tourism office, here you can find these hotels, for example, these restaurants, these cultural heritage sites. And we put all this in augmented reality and we made it publicly available for everyone. So anyone who has a smartphone downloads the Layar app and points to the surroundings of Valls d'Olot can access to all this information. And we have created since then more than 5,000 points of interest. So there is a lot of information created here. We can skip this part because otherwise it will be quite long. Go back to the yes, please. Una altra iniciativa que vam iniciar, valgui la redundància, a la UOC va ser explicar quin és el model educatiu de la UOC amb realitat augmentada. A les seus de la UOC, la gent, els potencials estudiants, venen a saber com és estudiar a la UOC. El que vam fer va ser muntar una exposició física amb 6 punts d'informació en els que explicaven en un com és la biblioteca de la UOC, per exemple, en un altre com és l'avaluació a la UOC. I el que fèiem era, al punt de la biblioteca, doncs tenia una pila de llibres. Quan tu enfocaves amb un tablet aquella pila de llibres, et recuperava un vídeo interactiu que t'explicava com és la biblioteca virtual de la UOC. I així amb les aules, amb el model educatiu, amb l'avaluació, etc. Can you play the link, please, for a second? Us posaré només unes pinzellades per no fer-ho molt llarg. Així, quan enfocaves amb el tablet a qualsevol dels punts d'informació, recuperaves informació digital en format vídeo que t'explicava com era aquell ítem de la vida de la UOC per a un estudiant. So it's a very engaging way of augmenting your physical experience with digital information. Go ahead, please. Then the Cosmocaixa experience, we have seen it. Next slide, please. And then we have built for Solvia, the real estate agency, a wide variety of experiences. First, we developed a variety of experiences for the Barcelona meeting point in order to allow visitors to get in contact with the product, the kind of product that Solvia is selling, in a different way. I will just put the video because it explains by itself. What you will see is a compilation of different experiences that allow the visitor to get in touch with different houses in different ways. This was in an interactive experience in which, using your body and the Kinect sensors that Takashi was talking about, you can navigate a 3D model of a house and you can change different things of this house. You can change, for example, the floor, you can change the color of the walls, the pictures that you have in the walls, for example, etc. So you can fully navigate a 3D model of a house and personalize it with the gestures of your body. Then another thing that we did is to turn walls into video walls. With augmented reality, as Takashi explained, you can associate digital contents to any picture, any image you would like to. So in this case, Solvia had some marketing campaigns that we wanted to bring to life just from the wall. So we are turning every single wall into a video wall. Then you can do the same as you do with the walls with a catalog. Instead of just having a catalog with fixed pictures, you can add digital contents to the catalogs. And this applies not only to catalogs like IKEA or Solvia is doing, but also to learning materials, for example. Why not using digital contents in learning materials, in books? There are quite a lot of initiatives that are using these techniques for that. And finally, and very specific to Solvia's domain, real estate, we built an experience in which, using a touch screen, you could navigate also through the inside of a house. This time it was not using a 3D model, but it was using real pictures, 360-degree pictures that you could move around. So you could visit the real place from a touch screen. And this works in a smartphone, in a tablet, or whichever mobile device you would like to use. And finally, the next slide. What I just wanted to show you, until now we have seen augmented reality experiences, but we are also working in virtual reality. Virtual reality allows you to immerse in a different world. Augmented reality gives you additional information on top of the real world, but augmented reality builds a completely new world for you. So, yes, click the link. So what we are also building for Solvia, for this real estate company, is a virtual visit to one... yes, I'll need to log in. So what we build here is, what you are seeing here is a recording of what a user will or is experiences whenever he puts on virtual reality glasses. So once you put the virtual reality glasses, you can navigate at your choice through the 3D space of this house. So you can appreciate how are the different rooms in the house. You can appreciate how are going to be the exteriors, for example. How are you going to feel like being in your terrace in the future? And this, we are building this as a pre-commercialization experience. So the house we are seeing here is not yet built. There is a lot of people that buys their house on top of a map, on top of a design just, but they don't have the feeling, they don't have the impression of how it's going to be, how it's really going to be that house. With this kind of technology and experience, we are offering this experience. We are building very realistic 3D models that you can navigate and you feel really immersed. With the virtual reality glasses, everywhere you look, you are inside the future house that is going to be built, that it's not yet built. So it's a very powerful tool for Solvia to help them in pre-commercialization, for example. Because it really gives you the feeling, the sense of being there, so you have a closer idea of how it's going to be the house you're interested in. And That's all we wanted to tell you today. I hope you enjoy it and you get the opportunity to get to know in a closer look what is augmented reality and virtual reality, and especially the really interesting work that Takashi is doing in this field. There is one more thing that we haven't mentioned, and is that Takashi is working in the agriculture field also. They are building experiences in which, with virtual reality glasses, you can get the same feeling that we are getting with the Solvia flat, that you are visiting the flat. You can do it with your crops. So you can monitor your crops from distance from your house. You just get virtual reality glasses and you get a real image of how are your tomatoes growing, for example. This is built with the purpose of making agriculture more efficient. And when you have huge extensions of tomatoes crops, for example, it is very useful to build a robot that has a camera, a 360 degrees camera, that goes running through all the crops. So you don't need to move to your crops to monitorize how your crops are, because you are getting the direct image, the direct video of how the crops are from your house. And with the virtual reality glasses, you have the full view. You can turn around 360 degrees and especially focalized in whatever you are interested in. So I think that was all we wanted to explain today. I don't know if you have any question for Takashi or for me. And
yeah,
please, Pilar.
So I'm interested in clinical.
Sorry, pardon.
Pilar was asking whether there are some experiences in which you use augmented reality or virtual reality to teach basic anatomy, for example. Am I right? And which was the other topic that you mentioned?
Or like to learn how to position anatomic points in a patient.
Okay. Or learn how to identify specific points of the anatomy of the patient using augmented reality devices or virtual reality devices. Do you know some experience about that?
Do I know some experience? There is some experience, some example of such experience all over the world. But
So would it be possible, for example, because I guess physicians provide a lot of very complex information to patients on how to make an injection for diabetics or use a nebulizator for asthmatic patients. So do you see potential use to provide this kind of instructions from the prospect of a drug or a device saying, look, this is the way you use it, instead of sending a video or something? Is that a potential use of augmented reality also to improve information for patients?
I think that the work that it's been, Takashi has an alternative branch that goes in that direction. We know about experiences right now that they, for example, printer builders like Epson, for example, they have developed experiences with augmented reality in which once you open your printer, you don't want to read the manual or whatever to install it. So you have a QR code that you scan with your smartphone, and you have an app that just pointing at the printer, it starts to generate augmented reality explanations on your printer on top of your real printer that you have bought, telling you, okay, you first have to connect this cable here. Once that you connect the cable, it recognizes that you have done so, and then it goes for the next step. Then you have to put paper here. Once you put the paper, it recognizes and goes to the next step. So the same could be used for any kind of process that you would like to explain to a potential customer. So it can be applied in a lot of domains. For example, now that you mention injections, I know about an experience of a kind of a scanner. Maybe it's not the technical word for that, but it's a scanner that uses augmented reality and infrared light in order to show the medical, the physicians or the nurses, in order to show the veins, the actual veins of the patient. So you can clearly identify where are the veins and where are the points where you can have the injections. These are some medical devices that are being built right now. There are some prototypes. I have seen them in action, and it really makes wonder, because raise the hand, the one that hasn't gone to have some injection and has been having problems because you couldn't identify clearly, or the nurses couldn't identify clearly where to do the injection. So this is another potential application. And Takashi has shown at the beginning a slide in which the actual bones of the patients were mapped on top of the physical structure of the patient. So this is another application of augmented reality that really serves to identify internal structure in terms of bones on top directly of the real arm of the patient. And these are some use cases that there are a lot of, there are some prototypes about it, and I have had the chance to experiment with them, and they really work. It's not just some Photoshop or some video, it's working. And the potential is amazing. There are a lot of applications for that. So Takashi, thank you very much for your talk. It was really a pleasure to have you here. I hope you enjoy these days in Barcelona. Takashi has had the opportunity to visit already some of the typical places in Barcelona, and he's really a gastronomical fan of the Spanish cuisine. And that was all. Thanks a lot for coming here, and I hope that we have learned something new or some new applications today that could be useful for you. So thanks a lot. Thank you, Takashi.
Thank you very much.